All right, and welcome back. So today we are going to be talking about a new type of graphing. So far we have been focusing on slope-intercept form. Today we are going to be talking about a brand new form that is called standard form. And the essential question that we are going to be completing today is how can you describe the graph of the equation ax plus by is equal to c? So before we get to there, let's talk about a real life situation that we might have encountered before. So you sold a total of $16 worth of tickets to a school concert. You lost track of how many of each type of ticket that you sold. You know that an adult ticket is $4 each and a student ticket is $2 each. What we are going to try to do is figure out what possible combinations of adult tickets and student tickets that we could have sold, although we lost track of it. Within the middle of your screen, let me circle it for you. This is going to be our general setup. We're going to have the adult ticket price times the number of adult tickets that we sold. We're going to add that with the student price. We're going to multiply that by the number of student tickets that we sold, and that's going to be equal to our total. So with that, let's look at part A. Let me erase a circle first. Let's look at part A. It says let X represent the number of adult tickets. Let Y represent the number of student tickets. Write an equation that relates X and Y. Let's refer back to the situation. Let's reread it again to help us create the correct equation. It says you sold a total of $16 worth of tickets at a school concert. You lost track of how many of each type of ticket that you sold, but you know an adult ticket is $4 and a student ticket is $2. Remember, it's asking us to let X represent the number of adult tickets and Y the number of student tickets. So let's write an equation that relates it. Try it out. All right, so if we were using the template that we were given beforehand, we know that it's the price for an adult ticket times the number of adult tickets. Well, we know that an adult ticket is $4. So we're going to have 4 times X, because X represents the number of adult tickets. And we don't know how many we sold, but we know they were each $4. So we have 4X. Now we're going to add that with the student price, which was $2, times the number of student tickets. Well, we're given that Y is going to represent the student tickets. So it's going to be 2Y, $2 for every student ticket. And that's going to be equal to our grand total. Our grand total was $16. So whatever combination of tickets that were sold, we know there were $4 for every adult and $2 for every student. We know that combined, we gathered $16. So that's going to be our equation. 4x plus 2y is equal to 16. $4 per adult ticket plus $2 for a student ticket. That gives us a grand total of 16. Now with this, I'm going to ask that you work on part B. Copy and complete the table showing the different combinations of tickets that you might have sold. So let's just do one together. The top row says a number of adult tickets, that's X. The bottom row is a number of student tickets, that's Y. Well, let's pick a possible number of adult tickets that we could have sold. Let's say there were 0 adults. Let's say there were 0 adults that showed up. That means when we go back into our equation, 4x plus 2y equals 16, we can substitute the value of x as 0. So really, underneath here, I'm going to write 4 times 0 plus 2y is equal to 16. Because we're letting the x value be 0. We're saying, hey, if 0 adults showed up, how many students showed up? And now we can simplify and we can solve this. We eventually get 2y is equal to 16, and we find that there had to be 8 student tickets. So this is the process that you are going to be completing. Whoop, should be the eraser. You are going to be substituting in some kind of given value, and we are going to be figuring out how many of the other subgroup could have been there. If you let there be 2 students, well, how many adults had to be there? If you had 5 students, how many adults had to be there? Is that even possible? So by us completing this equation and starting to choose set values of number of adults or number of students, we can find the other value. And even if it's possible to have that number of adults or that number of students. So please complete the table finding 4 more values. All right, so I'm just going to rattle off a couple of different values that you could have had. Now, this might not match up your table perfectly, but I'm just going to rattle off a couple of different values. Let's say you had 0 students there. Then you would have had 4 adults. Let's say you had 1 adult. That would be 6 students. Let's say you had 2 students. And that would have been 3 adults. Let's say we had 2 adults. Then that would have been 4 students. Those are some possible values that you could have used. Now, let's make sure we have this table down because we're going to have to know it in order for us to complete the next section. So please take a quick moment and copy down the table if you have not already done so. All right, let's carry on. So we're going to be talking about how to graph this equation, but we're going to be able to plot the points that were from the table. So you should have your table handy for you. So let's start to plot a couple of these values. Now, before we start to plot, let's just make sure we know what each axis represents. Well, what did the x-axis represent? If we aren't sure, let's go back. The x is the number of adult tickets. So underneath the x-axis, I'm going to write adults, which means that my y-axis is a number of students. Very hard to write vertically. If you want just to turn your paper and just write it horizontally, that's fine. It is very difficult to write vertically. All right, so let's look at a couple of different points that we had. We said, okay, if there were no adults, so that's 0 on our x, there were 8 students. We then said, well, if there were 4 adults, so that's 4 on our x-axis, there were 0 students. Those are 2 points. Another point, we said, hey, if there was 1 adult, there were 6 students. We also said, okay, if there were 3 adults, there were 2 students. If there were 2 adults, there were 4 students. So now that we plotted the points, what are you seeing maybe is forming from these coordinate points? Yeah, we're starting to see a line. We're starting to see a relationship between all the points. We're starting to see that we can create a line from it. And this is a straight line. So this is another type of linear equation. We've been talking about slope-intercept form as being one major linear equation. But now we're talking about standard form, which is another type of linear equation. Because as we write the equation and we get some coordinate points, we can graph it and it's going to create a straight line. Now, if you remember how many adult tickets you sold, can you determine how many student tickets you sold? Please explain your reasoning in the box below. All right, so let's just again quickly talk about what we're trying to accomplish today, and that is understanding standard form. So here's the key idea. Standard form of a linear equation is ax plus by is equal to c, where a and b are both non-zero. Or I'm sorry, let me read the verbatim, where a and b are not both 0. Pretty much a and b have to be numbers. They can't be 0. Have to be 1, 2, 3, 4, -5, -10, a half, whatever. It just cannot be 0. So ax plus by is equal to c is going to represent standard form. And we see standard form happens a lot with real life situations, as we saw with the adults and the student tickets. So let's graph this equation together. We have negative 2x plus 3y is equal to negative 6. What we need to do is we are first going to try and develop a table of possible values that could satisfy this equation. So we are going to make our chart. We're going to make an x and y table. Now you can do this vertically, you can do this horizontally, whichever way you want to. Here's my biggest Q-tip. Since we are able to freely choose coordinate points, or at least one value of the coordinate point, I should say, you want to use 0 for both the x and the y. So if we let x be 0, we can solve for y. If we let y be 0, we can solve for x. Now, let's go about it and just do these first two, and then we're going to find a third one. So if we have the equation negative 2x plus 3y is equal to negative 6, let's look at this first instance. Let me color these, that way it's easier for us to determine. So if we are letting x be 0, what we're going to do is we're going to substitute in the value of x as 0. So now, negative 2 times 0 is, well, just 0. So we're left with 3y is equal to negative 6. Therefore, y is equal to negative 2. So that means when x is 0, y is going to be negative 2. And now we're going to do this process again. We're going to do it for our y. Okay, so now we're going to let y be 0. So we have negative 2x plus 3 times 0 is equal to negative 6. 3 times 0 is 0, that cancels out. Therefore, we get negative 2x is equal to negative 6. We divide by negative 2 on both sides, and we get x is 3. And now we just have to choose one more value. If you have the ability and you think it might work, you always want to try like 1 or 2. Keep it easy. Keep it simple. So let's let x be 1. Let me put that in blue. Let's let x be 1. So we're going to try this process all over again. So what is the value of y when x is equal to 1? All right, let's check it. So if x is 1, we have negative 2 times 1 plus 3y is equal to negative 6. Negative 2 times 1 is negative 2 plus 3y is equal to negative 6. Going to add 2 on both sides. I'm running out of room here. Get 3y is equal to negative 4. And y is equal to technically negative 4 over 3. So here's the issue. Sometimes when we use this guess and check method, we don't get friendly numbers. So we get y is equal to negative 4 over 3. We can't really graph that well. So we're going to have to try out another number. Ugh, I know. So tough. No cap. So let's let x be 2. Let's see if it works when x is equal to 2. Well, we plug it in, negative 2 times 2 plus 3y is equal to negative 6. Negative 2 times 2 is negative 4 plus 3y is equal to negative 6. I can already tell that this is not going to work. So guess what? We have to try another one. Oh no. Guessing and checking is not fun. It's not fun, I know. Let's say we already have 3 for x. We know that 1 and 2 didn't work. How about we try -3? Let's see if that works. So we have -2 times -3 plus 3y is equal to -6. Positive 6 plus 3y is equal to -6. We're going to subtract 6 on both sides. That cancels out. We're left with 3y is equal to -12. We divide by 3 on both sides. Huzzah! We get that y is equal to -4. And it took a while for us to get that because guessing and checking is more difficult, right? But it's okay because we're trying, we're pushing through it, and we're trying to figure out, hey, what works? What makes it easy for us? We already know that those other values would have worked, but it would be tough for us to graph, and we want to be able to graph these. So now that we finally have 3 corner points, let's graph it. So the first corner point is going to be 0, -2. Second corner point is going to be 3, 0. Then we're going to have -3, -4. And what do you see is forming? Yeah, we're going to have a straight line. It's going to look something like this. Let me extend it. Awesome. So that was a bit tougher, right? That was a bit tougher by this whole guessing and checking method. If only there was an easier way. Well, lo and behold, we have an easier way. We have this process by graphing using the intercepts. Using the intercepts. That word should ring a bell. We were talking about slope-intercept form prior to today. Well, slope-intercept. What does it mean to be the y-intercept? Well, the y-intercept is where our line hits the y-axis. So if we're going to be using a process called using the intercepts, we're going to find the values of both the x and y axis. That's the x-axis and the y-axis. And let's quickly glance at what it means to be on the y-axis and what it means to be on the x-axis. If I am on the x-axis, let's highlight it. What is the value of y every single time on the x-axis? Well, let's just have a couple different coordinate points. This is 4, 0. This is -2, 0. -10, 0. What is the shared value every single time of the coordinate points? Yeah, y is going to be equal to 0. So if we are on the x-axis, that means that y, we're going to let it be 0. And now let's try it the other way. If we are on the y-axis, I probably should change colors there, whoops. If we're on the y-axis, what is the value of x every single time? Well, let's look at it. This is 0, 1. This is 0, 10. This is 0, -10. What is the value of x every single time when you're on that y-axis? Yeah, we're going to have x is always equal to 0. So if we're trying to find the intercepts, we can find it by letting x be 0 and finding the y value, letting x be 0 and finding the y value, and letting y be 0 and finding the x value. That's how we can use our knowledge of intercepts to help us figure out 2 quick coordinate points. So let's put it into play here. So if we have x plus 3y is equal to -3, and we want to find the x-intercept I hope you're writing this down. We are going to let y be equal to 0. So now we go into our equation, x plus 3 times 0, because we're letting y be 0. You're going to see that 3 times 0 cancels out, and look at that. X is equal to negative 3. Therefore, the x-intercept is negative 3, and we can graph it. We can go on the x-axis. We can find negative 3. This is negative 3, 0. And now we do the process again. X plus 3y is equal to negative 3. If we are trying to find the y-intercept, that means that x is equal to 0. So wherever we see x, we're going to replace it with 0. So 0 plus 3y is equal to negative 3. Well, our 0 cancels out, and now we can divide both sides by positive 3, and we get that y is equal to negative 1. Therefore, our y-intercept is negative 1. So we have the coordinate point 0, negative 1. And that's how we're going to graph by using the intercepts. By having this understanding of what it means to be an intercept, we're going to be able to graph using the intercepts. If we're trying to find the x-intercept, where that line is going to hit our x-axis, we let y be 0. If we're trying to find the y-axis, where that line is going to hit the y-axis, we let x be 0. And now that we have 2 points, we are free to graph. Let me extend all the way through. If I didn't, it wouldn't be true. Awesome. So I'm going to ask is for you to graph this linear equation using the intercepts. If you want, for right now, since you might not have graphing paper with you and it might be a little bit tougher to graph, all I'm going to ask are what are the x and y intercepts? Please let me know. The equation is 2x minus y is equal to 8. All right, so let's find the x-intercept. So that means that y is going to be equal to 0. So we have, again, the equation 2x minus y is equal to 8. And we're going to let y be 0. So 2x minus 0, that should have been in green. There we go. It's equal to 8. Therefore, we get 2x is equal to 8. We can divide both sides by 2, and we get that x is equal to 4. Therefore, the x-intercept is 4. Therefore, x-intercept, cool. So now, let's redo it, and let's find the y-intercept. Again, that means that x is going to be equal to 0. So we have 2x minus y is equal to 8. We have 2 times 0 minus y is equal to 8. 2 times 0 is 0, so we're left with negative y is equal to 8. But we did not solve for y. We have the opposite of y is equal to 8. So we can divide both sides by negative 1, and we get that y is equal to negative 8. So therefore, our y-intercept is negative 8. We can eventually graph these. So we have 0, negative 8, and 4, 1, 2, yep, 0. Now that we have 2 points, we can draw a line. Awesome job with this so far, kiddos. Keep up the great work. Let me know if you have any questions, and I'll talk to y'all soon.